All right, so I found out that there is a time limit on my free version of this extension, so sorry for the choppiness. But I guess that means I should keep going and do it quickly. So here's where we left off. We said for each letter in the word, if it's an A and the next letter is not an A, swap them. But if that's not the case, so let's say otherwise, like let's say I have an E, well, don't do anything. Just include that letter. So how about I write and or how about we'll say keep it the same because really we don't know that we're building a new one yet. Keep it the same. All right, now I want to note something really important here. Right now, I probably have between a 0-point problem and maybe possibly, if I was really, really lucky, which I doubt, 1 point out of 4. Actually, out of 5 on this one. So I haven't earned any points yet. But what I did do is set up all the things I have to do to make sure that I can get through this problem. So now we can go back and actually write some of the code in. And we don't write the code for the whole problem. We write it a line at a time. We solved the logic in English. Now we're going to do the program in Java. All right, so let's take this first line. For each letter in the word. Well, there's a really easy word that jumps out at me, but even if I didn't have that, each always tells me for loop. For int I equals 0. Always start counting at 0. I is less than, I'm curious about the word, so maybe the words dot length I plus plus. Now keep in mind, I'm writing in pencil, so I might be going back to change that at some point. But for the time being, for each letter in the word, that looks okay. What do I want to do for each letter in the word? If what's. What are we talking about? We're talking about the letter in the word. I got to get the letter out of the word. There's a really useful method that's not in the AP subset, meaning they don't expect you to learn it, but it makes your life a lot easier if you do. The method's called care at. So if I say word dot care at the character at a position. Well, which position am I currently at? I'm talking about each letter in the word. So I'm going to be looking at each one. I'm not always looking at the first or the third or the seventh. I'm looking at the ith. I is keeping track of my place. So if word.care at I, the ith letter is 2 equal signs to say, is it equal to? If it's an A. And we know it's a capital because it said so in the precondition. If it's an A, and, oh, that's easy to translate. And the next letter is not an A. So, word dot care at I plus 1, that's the next letter, does not equal A. Now, right at this point, my spidey sense is tingling. Any time that you do something like this, I plus 1, you gotta be thinking of bounds errors. You're saying, look past my current position. This, I is less than word.length, guarantees that I will never get to the actual length, because that would be a bounds error. 3 letters in the word, the last position is position 2. But if I say I plus 1, well, now I'm going to be saying 2 plus 1 is 3. That gives me a bounds error. So I got to think of a way to fix this. There's a couple things you can do. One of them would be to say, take a -1 here, meaning you never look at the last letter. Another one could say, well, if I'm looking at the last letter, I really don't care anyway. I mean, if you think about it, no matter what, even if there's an A at the end, is the example I used earlier. If there's an A at the end, you're not going to do anything with it anyway. So maybe the last letter we really don't care about. So maybe what we do is just say, and you're not at the last letter. But then this becomes really cumbersome. Then it's a really compound statement. So I think what I'll do, since I was using a pencil, is I think I'll go back up here and say length -1, I plus plus. And now I just got to make a note to myself down here somewhere. How do we say? Fix last letter. Because now I know that that last letter may or may not be in there. You'll see in a minute why it could be. Could be. So here we go. If it's an A and the next one's an A. By the way, at this point, you have a couple points. You got a point here for going through and not getting a bounds error. And you got a point here for checking for the two A's. If we stopped right now, you got 2 points, which is pretty respectable on an AP problem. But we're not okay with that. Let's keep going. If it's an A, the next one's not an A, swap the places. Well, here's the problem. We can't swap the places in a word. I can't change anything in a word. What I can do is I can build a new string. So what I might do instead of swapping the places is say S word, that's scramble word I'm making, plus equals, so add to yourself. Remember, I'm swapping them. So instead of saying add the current letter and then add the next letter, I might say add the next letter first, word dot char at I plus 1. Then I also have to add that A back in. Since I know I'm guaranteed it's an A, I might just say end A. That's a little bit easier to write word dot char at I again. But if I see those two, swap them. Now, here is a problem. I'm just going to slide this stuff down. Let's say otherwise keep the same, right? Otherwise, keep the same. Here's a problem we have, though. I just added 2 letters to S word. I'm looking 1 letter at a time. As soon as I swap something, so if I'm going through tan, T-A, or let's do, how about tank? So I'm going to build 1 letter at a time. T doesn't get swapped. A, look at the next letter, right? So look at the next letter. It's not an A, so swap them. N, A. Well, my for loop says go to the next letter, which is now an A. If I start looking at that, I might add too many times. So what I'm going to do is say, just added 2 letters to the word. I really want to go a little bit further. So I'm going to force my for loop to skip a turn by putting another I++ in there. I got to contain that in that if statement. So if I have an A and the next one's not an A, swap them or add them in. Add 1 more. I added 2 letters, so I need to look 1 further. What if I didn't do that? Otherwise, this is an easy translation. Otherwise is 99.9% of the time the word else. Keep it the same. Well, if I want to keep whatever letter is there, instead of adding char at I plus 1, I'm just going to say S word plus equals word dot char at I. Boom. And we'll put our closing curly brace. So if I see a T, doesn't meet this condition, just put it in. What if I see 2 A's in a row? So what if you have aardvark? A, R. Doesn't meet that condition, so put down the A, go to the next one. Those 2 are going to get swapped. So this looks like it's working. But remember, we wrote a note earlier. We got down to here, we said, hey, fix the last letter. Because there's one problem. The problem is we're skipping the very last letter of the word. And we could just say, just add the last letter of the word. But that's not going to work for us because we may have already put it in. This is looking 1 letter forward. We may have already put it in. So really what we need to do is this. We need to say, if S word dot length is less than word dot length, well, that means we didn't put that letter back in. We didn't account for it, right? So let's fix it now. Oh, I only got 10 seconds. So we're going to say S word plus equals last letter of word, return S word. This is not the only way to solve this problem, but